All right, welcome everybody. In today's webinar, we'll be talking about the brand new library that was delivered by Johnson Labs, which is called NLP Test. The aim of the library is to deliver safe, fair, and robust language models into production. So we've all heard in the NLP community and in the broader AI community about risks around bias and lack of robustness in many AI models, and particularly in the NLP field with the rise of uh, more public applications like ChatGPT. And over time, this has ended up leading mostly to a few publications, academic publications, which have highlighted these different problems. But in the end, in terms of concrete toolkits or concrete implementations in production systems around the industry, this hasn't really materialized. And so it's with this idea that we ended up developing this new library, so NLP Test. And I would say these are um, the four main papers that inspired the development of the library. Really the most important one being the checklist paper by Ribeiro and colleagues, which basically showed that by applying certain perturbations to input texts, NLP models would often fail to carry out consistent predictions. And so based on the paper, there was a library implemented, like a Python library that was implemented and that people could use. So that was really the the first concrete starting point of um, the testing capabilities in the NLP field. We then had a really well a series of papers that came out around bias, but the most I would say concrete one with really concrete examples and applications was the BBQ paper, which actually didn't come out that long ago. It was last year by Parrish and colleagues, which showed that um, by testing models for question answering and by creating certain perturbations around biases that are related to race, gender, disability, religion, etc., you could change basically the final answer of the model um, in a large percentage of the time. There are some other papers that came out, especially in the clinical world, around things like biases around ethnicity. Um, there are also things around data leakage, which is a topic that's quite important in clinical NLP. And so basically, like going around with these papers, we ended up finding that there was really a lack of concrete of a concrete toolkit out there to be able to implement and actually test your models. Um, and so we came up with a internal framework to do this. Um, the first concept that was really central to all this is that we wanted to include this concept of really testing your models thoroughly. So instead of just getting accuracy metrics, which is what most people do before deploying a model into production, we actually wanted to test the models very thoroughly, just like uh, software engineers carry out or write unit tests to test their software. The second framework, or like the second main point that we referred to while creating this is that we didn't want, or we wanted to warn people against using or reusing academic models straight in production. This is because models that are released as part of research projects are often built just for the purpose of research, and they have not been deployed into the real world, and they have not gone through the test of the real world, which sometimes tends to break models in production. And the final thing, as I was saying, is that beyond accuracy, we want to be able to test other aspects such as robustness, bias, fairness, toxicity, efficiency, safety, data leakage, etc. And it's with these three frameworks, or these three main points, that we went out to build the library. So introducing this library, it's really it can be summarized with these 3 points. It's very extremely simple to use. So with a pip install NLP test, you can then generate and run test cases automatically on, there are more than 50 different test types that you can run on the most popular NLP tasks, whether it's token classification, text classification, question answering with LLMs. This can be done really in 3 lines of code. It's comprehensive because we try to test all the aspects other than accuracy of a model. And of course, it's open source under the Apache 2.0 license, which means that it's commercially, usable, and you can easily extend it to your own use case, add your own test types, um, and test other tasks depending on what your use cases are. This is, I would say, I often refer to this as the main, the main way to describe the purpose of the library and the workflow that is meant to describe how it works. So usually, when data scientists train NLP models, they train the model and then they go straight to running accuracy tests. And if the model passes a certain accuracy threshold, they go ahead and release the model. Or if it doesn't pass the accuracy threshold, they usually try and go identify what the different errors were on their test set or on their validation set, and they try to come up with different hyperparameters, or they increase the size of their training set, and then they retrain the model until the accuracy passes a certain threshold. So the way we're trying to disrupt this is to really come in and implement this mindset of carrying out unit tests. We go ahead and, once a model has been trained, we go ahead and automatically generate test cases, excuse me, which are around, biases, aspects like bias, robustness, accuracy, of course, which should always be considered, fairness, and a couple other. Once the test cases are generated, we run them. And once you run these test cases, you end up with some kind of report that tells you, whether the bias tests have passed or if they failed. And depending, for example, if in your series of test cases, one test category like robustness ends up failing, the the um, the idea here is that you want to be able to go and fix that. So fix your model basically, and not go directly into production, because there are risks associated with these different things. So, for example, for bias, you might make the headlines around, if your model is discriminating based on age or ethnicity, for example, robustness in certain critical applications, if your model is unable to deal with typos, um, if it gets completely messed up by typos, um, then it's really just not ready to go into production. And so what we do, instead of just telling you that you haven't passed your bias test, you haven't passed your robustness test, your accuracy test, etc., we actually go ahead and augment your training data, not your test data, and we augment that data so that you can retrain your model and hopefully pass those tests on the second iteration. And if not, you just keep going the cycle. And once all the tests have passed, you can go ahead and release your model. So of course, we set out to not just support Spark NLP from Johnson Labs, but try and build this as a toolkit that can be used in most of the major or really all the popular frameworks out there for NLP. And nowadays for LLMs. So these include especially, of course, Johnson Labs with Spark NLP, Hugging Face Transformers, spaCy, and around the the tasks around LLMs, we have support for OpenAI, Cohere, AI21 Labs, so the Azure OpenAI API, and we're building all this on top of the LangChain supported APIs. So the way we'll see an example in a notebook in a second, but the way, as I said, that we do this is extremely simple. Once you've pip installed NLP Test, you just have to run 3 lines of code to get started and generate a report and run your tests. So what you do is you import the harness class, which is the main testing class. So it's a test harness, which is a concept you might be familiar with. Within this harness, you then define the task, which in this case, in this example, we're doing question answering. You define the model. In this case, we're using GPT 3.5, which is the model used, that's powering ChatGPT for certain people. And then the hub, which in this case is OpenAI, but as you know, this could be so Johnson Labs, Hugging Face, spaCy, etc. And the data. So in this case, since we're testing an LLM, we're using a benchmark data set, which is BullQ. So it's the test set, and we call it tiny because it's a subset of that test set, actually. Um, and this is the case for LLMs, where you're going to be able to choose from a set of benchmarks. But for other tasks like NER or for text classification, the user here is the one that's passing in the their data set to the test harness. And we end up reading that data set and generating test cases from that data set. So the first thing you do here is you generate your test cases for that given task, model, and dataset combination. And the second thing you do is then to run those tests, and that generates some kind of a data frame with each test case and whether it passes or not. And then the third thing you can do when you call the report method is to generate some kind of summary report, as I was saying in the beginning, of whether bias tests have passed, robustness tests have passed overall, or not. And really, that's as simple as this. You're good to go. So in terms of what kind of test cases are actually generated, you'll be able to see here a couple examples. This is from an infographic from our website. Let's take an example around ethnicity, for example. So we have here 2 sentences which go through a text classification model. We have Jonas Smith is flying tomorrow, which has been given a neutral sentiment by the model, the text classification model. And then here we have a second sentence, which we've basically transformed the name Jonas Smith to another name that's typical of a different ethnicity, for example, which in this case would be Abdul Karim. So Abdul Karim is flying tomorrow. Let's imagine here the model has detected this to be a negative sentiment. Then we would have here a clear example of a model that is, showing some kind of signs of some kind of bias. And this is something that can, for any company could end up making the headlines. So these are the types of tests that we really encourage people to carry out on their models to be able to make sure before going into production, before people actually start using those models, to make sure that um, they can pass these thresholds. So once you um, so to generate your test cases, as you saw earlier, you called the .generate method, and here we have an example of what that method would yield. We have these different test types, so add typos, add context, replace the Hispanic name, etc. So you have your test case. So you see, let's take the very first one. So add typos. So Wang Li is a doctor. So in this case, a typo has been added. Quite obviously, like the U here used to be an O. And we want to make sure that once, so this is the test cases, we want to make sure that once this sentence passes through the model, the NER model in this case, Wang Li still gets detected as a person and doesn't, not become, doesn't go undetected. And you can do this with different things. Here, for example, for replace a Hispanic name, we replace Wang Li to Juan Moreno. And in this case, we're expecting that Juan Moreno will be detected as a person and not go undetected. In this case, if it would go undetected, then we have some kind of issue here with bias, or maybe your data set needs to be more representative of that certain ethnicity. And if you're going to be deploying that model in a country where all the names are Hispanic names, then you're probably in trouble. So the next thing to do when you call .run and .report, as I was saying, it produces some kind of summary. And so in this case, it's telling you like your robustness tests are not passing and your fairness tests are not passing. And when that happens, you basically go ahead with like you're basically not ready to go into production and deploying your model. So at this point, you have to go ahead with our automatic data augmentation, which is the next step here. And in this case, you can do this. I mean, you do this in one line of code, and then you can reload your model and then retest it. So we can dissect this together. So once, let's say you've called harness dot generate dot run dot report, and you get this, you see that these two don't pass. You go ahead on your harness, you call the augment method. You, as an input path, you give your training set, and so not your test set. That would not be a good idea, since you should keep your test set totally separate. And then you define an output path for somewhere where we're going to be able to store your data set, your augmented data set. You then, in this case, this is an example with the Johnson Labs library. You then load a a particular model, whether it's a text classification or token classification, and then you fit on the augmented data set. And so this is basically you're just training a new model on that augmented data set. And once that's done, you can retest your new model and make sure that it's actually passing the test this time. And in most cases, we show that this is the case. So when you augment your training data, especially for robustness tests, you get a model that's much more robust and able to pass your test cases. One thing I will add here is that if you saw all the different pass rates here, these are entirely customizable, and this is really important because um, certain um, certain companies or certain applications will require different standards. And so, for example, let's say robustness is something that's absolutely important to you. You need at least a 95% passing rate. Then you're going to be able to set your minimum pass rate to 95% so that all your tests are evaluated that way with that high standard. Because conversely, if robustness is something that's really not important at all, your model is always going to get the same type of input data in production, then robustness might not be important. You can lower your standard and uh, go on with the deployment of the model. So this is it for the theoretical part. Well, we'll jump into a notebook, but I just want to highlight here a couple links to get you started. The NLP Test website is quite simple to remember, nlptest.org. We have a GitHub repo, which is getting more and more community interest and involvement, which is great. So I recommend you to go check this out and try out the library. And finally, we have a community Slack channel, let's say, where you're going to be able to interact with the different members of our team and get some answers around the different questions you may have. So let's dive into it. So I'll just show you first the website, nlptest.org. We have it right here. So you'll see this is a landing page where you're going to be able to just get an overview of what I've just presented, how to download it, how to use it with different libraries, different frameworks. But more importantly, you're going to be able to check out some documentation around the library. So what is a test harness, hubs that we support. For example, here you see, Cohere, AI21 for LLMs, etc. There is I'll get to tutorials in a sec, but there's a test page where you're going to be able to really review all the different tests that are available. As I said, there are over 50 tests, which is a large number. So you'll be able to parse through these and check, where they're coming from, what is their, how they were curated, and you're actually going to get access to links to be able to, if you wanted to customize these different tests, you would be able to. And when I talk about customization, you actually have this repo, the GitHub repo. So NLP test here, Johnson Labs /NLP test, where you're going to be able to dive into the code base, just collaborate with the different contributors of the project. We also have a discussions page where you're going to be able to keep up with the latest releases, like release announcements. We encourage you to go into these different discussion categories here. Whenever you have an idea, for example, or just a question around how to use a library, feel free to create a new discussion here, or you can go on the Slack channel. And then for those that want to get even more technical, to contribute, new tests, to customize the tests on your own in your own environment, you can check out here the NLP test folder, where you're going to be able to do different kinds of additions to be able to suit your use case. And I think, yeah, this is pretty much it for the repo. We'll jump right into a tutorial notebook. So here in this page, we have a tutorial section where you'll be able to, to just go through different tutorial notebooks available. So I'll just show an example for those that are quite interested in LLMs and how to go ahead and test them. We'll open this notebook and just run through it together. So you'll see every notebook is really quite detailed and carries a lot of explanation. So I encourage you to check them out and really read through them and to understand how the library works and what you can do with it. So as I said, pip install NLP test. Then you import your harness. This again here we explain like what are the different parameters available for the harness. This is also available, as I said, in the docs. For OpenAI, if you're going to be using OpenAI, you're going to have to define an API key. once that's done in your environment as an environment variable, once that's done, you can create a test harness. In this case, we're going to be testing question answering with this model, GPT 3.5 Turbo, on the tiny BullQ test set. So for question answering, here when you're testing a model, it's going to download this data set, which uh, so for certain tests, so for bias tests, it's going to download this data set. For robustness tests, it's going to apply perturbations on the fly. Um, but everything's happening automatically in the background, and you end up being able to carry out all these different tests. You define this, which tests you want to carry out and what threshold is fixed for them. You can define this in a config file or in a configure method here for the harness. The configure method looks kind of messy, so we always recommend to just go ahead and use a config file. We actually show you what that looks like in this website. So you'll be able to define your tests, um, and then you can define some default passing rates or default scores depending on the tests. Or if you want to define specific passing rates or specific scores for certain tests, you can do that also. So you define your test categories. So here we have robustness, bias, and accuracy, and you can then either here you see for bias, I'm just defining one test, replace the female pronouns, and I'm not setting a default pass rate because I'm just going to use the default here. Whereas for lowercase and uppercase, I'm going to bring down the default is a bit too high for me, so I'm just going to bring it down and set it to 0.6. And that's pretty much how you do it. And as I was saying, the other option is to do it through this configure method that takes in a dictionary. In this case, this config takes in some model parameters because we're using an LLM. Here we're going to be defining some max tokens. This is controllable. You could set this to uh, 16 tokens, for example, if you want some really short answers for question answering. You can also add something like temperature. So whether you want your model to be completely as blunt as possible. So here I would set a temperature of 0. And then for your tests, as you saw earlier just now, you can set the pass rates in which tests you may want to run. You then call the generate method, which will generate the test cases as the name describes. You can actually print or display the test cases that you've generated by calling this .test cases. Here we'll see, it might be a bit overwhelming when you first look at this, but you'll see here we have a robustness test. So this is our first robustness test, lowercasing, where we have, let's take maybe this example since it has some uppercase. So we have the original question, which is, do the Champions League winners get automatically qualified? I'm assuming. The original context would be 2018 to 19 UEFA Champions League, blah blah blah. But you see here there's some uppercasing Champions League, and so what we do is then we perturb these examples, for example, and make them all lowercase. So you can see here in the context and in the question, well, the question is already lowercase, but the context becomes totally lowercase. So this is your test case: is if I lowercase my question in my context, does the LLM still predict the same thing? Hopefully it does. And you can check that by calling .run. So .generate .run to display your results. You can call .generated results and get some new columns here, which are expected result, actual result, and pass. So expected result is the model's prediction on the original question and context. So let's go back to the Champions League. So on the original context, it says true, like Champions League winners get automatically qualified. And on uh, the new question and context pair, it gets the same answer, so true. Um, yeah, I might have not said it before, but yeah, this is the bulk Q data set. So the models are supposed to predict whether um, like the answer is supposed to be true or false. Those are the only possibilities. Um, it's not a some kind of extractive question answering task. It's really a true or false task, question answering task. So those are your test cases. You can then check out a report. In this case, we ran like some short, just a series of two tests, and we see here that the model passed 96% of the lowercase and the uppercase test. And so our minimum pass rate that we set in the configuration was 70%, which clearly that has been passed. So these both get passed. And you can also, you can, if you're still not satisfied, in this case, these are quite simple examples, but if you're not satisfied with a particular test, you can go ahead and check the different issues that you might have, seen in your test cases and try to fix them. So yeah, that's pretty much it for this notebook. Um, So I would say that your best starting point will be this tutorials notebook section. You'll be able to test out the different notebooks and check out some explanations. Like if you're interested in bias, for example, you can open the notebook and try out um, the different explanations and like run the notebook, run the tests. If you're using spaCy, if you're using Hugging Face transformers, just go ahead and run these notebooks. So yeah, I think that will be it to conclude this webinar. Thanks for tuning in. Make sure to go to the repository and give a star. It will really help us out as a community. And yeah, make sure to come and interact with all of us. We're really happy to welcome everybody. Thanks again.